Hi all the students of Narayana 10th standard. Today here I am in front of you all to discuss your assignment number 9 from the topic current electricity. Let us go with the first question which is given in your assignment. Here the first question which is given for you all is the potential difference between the ends of a wire of resistance 5 ohm if 720 coulombs of charge passes through it per minute. Now whenever you get into this kind of a situation, in this kind of a question, you have to deal it like with the Ohm's law, V is equals to IR. So we all know that I is nothing but current is nothing but flow of charges with respect to time into R. Now what is this Q given as? R is given as 5, so I'll substitute it with 5, and Q is charges 720 by time is given as per minute, so I'll take it as 60 seconds. So this is 60. Now if I try to solve this, I'm going to get 60 volts is your answer. So it is option number 3. I think this is helpful. Let us get into the next problem. Now here comes your second question. This is your second question. Three resistors are there actually, R1, R2, R3. Let us take this one as R1, R2, R3, and this is R3. Now I am going to write it over here. This is R1, this is R2, this is R3. Now when we have 3 resistors and they are all connected in parallel, this is very important. Now the ratio of currents passing through them when a potential difference is applied across the ends. Let us take these all are connected parallel. This is R1, right? Now let us give it with some current I. Yes, we'll take it as I, and here it is going to get converted into I1, I2, I3. So this is R1, R2, R3, and again they come back with I. Number of currents entering is equal to number of currents leaving. Now here what happens is you have all the resistances in parallel. Now when I want to relate this I1 is to I2 is to I3, I1 is to I2 is to I3, I would like to relate it like this. Like the relation for this is equals to 1 by R1 is to 1 by R2 is to 1 by R3, because all of them are in parallel, right? Now I would like to apply this concept over here. Now I'll write it again over here. Well, this is I1 is to I2 is to I3 is equals to 1 by R1 is to 1 by R2 is to 1 by R3. Now here 1 by R1 is how much? R1 is 1, R2 is how much? 2, R3 is 3 ohms, 1 by 3. So my LCM is 6. So what happens over here? 6 is to 6 is to 3 is to 4. Sorry, 2. Right. So 6 is to 3 is to 2 is my answer. Like I'll be getting I1 is to I2 is to I3. Well, my answer is 6 is to 3 is to 2 when I am going to find the ratios of all the currents which are moving from each and every resistor in the previous diagram which I have drawn, right? So the answer is 6 is to 3 is to 2. Which option it is? Is option number, no, not this, 4. Option number 4. 6 is to 3 is to 2. Now let us get into the next problem. The next problem over here is right? The next problem over here is two wires of same material and having lengths in the ratio of 2:3 are connected in series. Like you have lengths given, like length is given like 2:3 ratio and connected in series. They are connected in series. The potential differences across the wires are 4.2 volts and 3.6 volts. Now 3.6 volts respectively, compare their compare their radius. So here one thing you have to know, that is V is right, let me correct it. V is directly proportional to R. Yeah, V is directly proportional to R from the formula V is equals to IR. From the formula V is equals to IR, so I can say V is directly proportional to R. Now from there what I am trying to do is, from there if it is V is directly proportional to R, whereas R is inversely proportional to the area. When I want to find area, inversely proportional, so I will write it as 1 by A. When I am talking about area, I would like to discuss it in the form of radians, which I am going to write it like R square, pi R square, because the area of a circle is going to be pi R square. Now I am going to take it as R square. So here what I am going to do, and this R is directly proportional to L. R is directly proportional to L. That means length. Resistance is directly proportional to length, and resistance is inversely proportional to the area. So when I like to substitute this, I would be getting it like in this way. Like I want the ratios of V1 by V2, which is nothing but it is equal to R1 by R2, because V is directly proportional to R. So if I would like to substitute it, I would be getting like L1 by L2 is equals to R2 square by R1 square. That R is radius up there. Now what happens over here? L1 is given 2, L2 is given as how much? I don't want this thing also. Okay, this is into over here because that gets reciprocal over there. So when I want the radians comparisons. So when I want radians comparisons, I will take that this side. I am going to get R1 square by R2 square is equals to, I will be getting L1 by L2 into V2 by V1. Now from here V2 is how much? This is V1 and this is V2. So how much I would be getting? Like L1 is how much? L1 I am going to substitute it like this, implies R2 square by R1 square is, sorry, R1 square by R2 square. R1 square by R2 square is equals to L1 is 2, L1 is 2 is to 3. I'll write it as 2 by 3 into V2 is how much? V2 is 3.6. 3.6 by V1 is how much? 4.2. Right? So now this is 4.2. Now if you solve this, how much should you be getting? Right, 4.2. So the option is 2 by root 7. You will be getting 2 by root 7. So your answer is option 2, which you are finding the comparison of their radians is 2 by root 7. You send that square that side, you are going to get it like 2 by root 7. You will be getting somewhat around 4 and all. So if you send that root that side, you are going to get 2 by root 7. So your option is second option. Hope this is helpful. Let us get for next sum. Right. Now in this sum, you can see that you are given several identical resistances, each of 5 ohms, and each capable of carrying a maximum current of 2 amperes. It is required to make a suitable combination of this resistance to produce a resistance of 2.5 which can carry current of 4 amperes. The minimum number of resistances required. So here what we'll like to do is we'll try to find out the resistances. Resistances over here is R. So what do we do over here? R is equals to we don't know how many number of resistances over here. So identical resistances are given, and each capable enough of carrying a maximum current of 2 amperes is required to make a suitable combination of these resistances to produce a resistance of 2.5 ohms which can carry a current of 4 amperes. Okay, so the number of, you then need to find the minimum number of resistances required to do this job. Now this is nothing but R by N. They are telling it is equal to 2.5. From here N value, if you try to find out, you are going to get 2. So here your current I is going to be equal to total current I1 plus I2, which you will be having somewhat equal to I is equals to ITIL, right, because this is I total current. So I is equals to 2 plus 2, because I need the resistances to accept at least 2 amperes of power. So each resistance have to accept 2 amperes of power. When if it is accepting 2 amperes of power, so my current from 2 resistances, my total current is nothing but 4 amperes, right? So now that is what I need. Like now I would like to find out I total by I. Now what is my I total? I total is 4. I total is 4, and what is the I over here? Minimum I is 2. 2 ones are 2 twos are. So my value is 2. So the amount of the minimum number of resistances required over here are to do this particular job is 2. So that is option number 2. Hope this is helpful for you. Let us meet in the next assignment. Until then, bye.